Welcome, class, to part 2 of our review of exponential functions. In this lesson, we will be examining domain and range of both growth functions and decay functions. You will not need your graphing calculator, so please put your calculators away. In addition, please take out your supplemental aid that looks like this. You will be able to download this if you have a printer. Please print it out. Otherwise, just copy what you see here so that you can have some documentation that you were participating. So please pause the video and copy everything that you see here either onto a blank sheet of paper or onto the pre-printed supplemental aid. In part 2 of our study of exponential functions, we will be determining the domain and range and represent the domain and range using inequalities. Part 2 is after what we've done yesterday, which was identifying A and B values, and we will continue on for a few more days in our study of exponential functions. What you see here is the red line represents the domain of an exponential function. Notice here that these arrows of the function are present. And so the mathematical domain, outside of a word problem, a real-world application, we are seeing that this arrow will continue indefinitely to the left, forever to the left, and this arrow going up will forever go to the right. Now, the range is very similar to that. I don't have it displayed, but I can display it on this. If the arrow goes forever to the down and forever up, then the range would be all real number. Well, I'm wrong in saying that it would be all real numbers. Let me repeat that. It's tempting to say that, but we do have what's called a horizontal asymptote here. This horizontal asymptote will never be crossed for exponential functions. And so the domain would start at the horizontal asymptote, and let me redo that. It'll start at the horizontal asymptote and forever go up. So the mathematical range of an exponential function would be all y values greater than 0. Notice they're not greater than or equal to, they are greater than 0. Okay, let's look at the range of this function, all y values greater than 0. The domain would be one of these. Domain would be all real numbers. Okay, now we begin to see the domain and range of a exponential function, but within the context of a graph, within the context of units, and within the context of a word problem. The domain will be, again, all values to the left and all values to the right. Well, we're in the first quadrant of a graph, and it looks as if that the domain is going to start and then move to the right because the graph itself moves up to the right. Let's first identify what the units are. What are the units of the x variable? Well, you're right. You have to look down along the x-axis, and the units are the number of years since an initial investment, and the graph is showing how that investment is growing over a period of time. What's the domain? Where does it start? Looks like it starts right here, but how is it moving to the right? And how would we express that with words and with inequalities? Well, the domain would be all real numbers greater than or equal to 0. And we would express it as an inequality. X is greater than or equal to 0. Equal to 0 because time starts at 0. The moment you deposit that money into an investment account and you let it sit there, it's going to start at 5,000. Looks like it's 5,000. Start at 5,000 and go up to the right. The range is the investment, the amount of the investment. And when I said it starts at 5,000, what I mean to say is that the y value will be 5,000. So time starts at 0, but the investment itself starts at 5,000. And it doesn't quite say dollars, but it's assumed to be in dollars. And it moves up. So the range would be all y values greater than or equal to 5,000. The range is all real numbers greater than or equal to 5,000. Here we have a different situation. The graph reflects the fox population in a wildlife preserve. And we're being asked what unit is used for the x variable. Well, look down along the x-axis. The unit is number of years since the initial count of fox. What's the domain? How far left does this graph go? It starts at 0, right? 0, 75. Well, the 0 is the x value, so we would say that the domain is all real numbers greater than or equal to 0. Oh, what is the unit for the y variable? Well, you're right, number fox. So the number fox, it starts at 0, 75. So 75 going upwards, 75 would be the least number of fox that we have, and that population of fox is increasing above that. So how do you think you'd say that? Well, it's tempting to say that the y values are all y values greater than, well, it's tempting to say that it's all real numbers greater than or equal to 75. But there's a little slight technicality here. The technicality here is that there are no decimal number of fox. You can't say you have 75.27 fox. How do you quantify 7.72 fox? It's either 75 fox, 76 fox, 77 fox. It's a countable number. So the range would be all countable numbers greater than or equal to 75. Number 3. This graph shows the depreciation of a computer system. Looks like it starts at time 0, and then it goes down to the right. Looks like it goes from 65,000 and goes down to the right. So what is the unit used for the x variable? Look down at the x-axis. What unit is used for the x variable? Well, you're right, number of years since the purchase of the computer system. Yes, if you have the booklet, please write that out. And what about the numerical value of that domain? And how would you express it with words? Well, the domain would be starting at 0 years since the purchase of the system. The domain moves to the right. And so think about it, years. Can years be all real numbers? Can years be half of a year, 1/4 of a year, 0.25 of a year? Yeah, it can be. So we would say that the domain is all real numbers. Real numbers indicate that you can have decimal values, fractions, parts broken up. So all real numbers greater than or equal to 0. What about the unit used for the y variable? Well, you're right. Look along the y-axis. The unit used for the y variable is value of the computer in dollars. And now let's look at the range. Starting at 65,000, the value of that computer is going to be going down from 65. So we have y values less than 65,000. All real numbers less than or equal to 65,000. But wait, remember what we referred to as what's called the horizontal asymptote. There's this horizontal asymptote here. That graph will never cross the x-axis. And so we need to remember that although, yes, the values are going down, it'll never cross the x-axis. This graph will never cross the x-axis. So I need to add a little something on top of this, or in addition to this inequality. What we need to write is this, the part here on the left. All right, and the way we would say this is that the range is all y values less than or equal to 65,000 but greater than 0. All real numbers less than or equal to 65,000, and the y values still have to be greater than 0. Never equal to 0, greater than 0. This one is interesting. This is the half-life of flea medication. Well, in a dog possibly, and or some pet. And at time 0, moves to the right. This medication, the amount of medication in a pet would be going down to the right, never ever crossing that horizontal or touching that horizontal axis. So let's begin to analyze this graph. What unit is used for the x variable? Time, yes, time in hours. Okay, what is the domain of this graph? Okay, look at how it moves to where it starts on the left, and how does it move? Looks, it's moving to the right. So how would you express that with words, and how would you express that with an inequality? Well, you're right. All real numbers greater than or equal to 0. There was a time at 0 when that medication was put into a pet. so it's or equal to 0, and it just continues on forever. That medicine will forever be in trace amounts of your pet. Less and less and less and less with every hour that passes, but the idea is that that medication will forever be in your pet. All right, let's look at the range. Well, the range looks like it starts at 20 milligrams, right? And then it just goes down, but it never crosses 0. So how would you write the range of this particular part of an exponential function, of this decay function? Well, first of all, let's look at the unit. The unit is the amount of medicine. Okay, so now how would you write the range? All real numbers less than or equal to 20 and greater than 0. So there's your range. All real numbers less than or equal to 20 and greater than 0. That one was a little tricky. I think the trickier ones are the decay functions, because you can never cross that horizontal asymptote. Never. So you have to know that it'll always get close to the horizontal asymptote, but never cross it. Okay, number 5. We're looking at a graph that indicates or shows the valuation of a technology company. A lot of times when these technology companies start young, they really do grow fast. So let's analyze the graph. What unit is used for the x variable? Write it down. You can talk it out. You're right. It's the number of years since the startup. Okay. And what is that domain? It looks like it starts at time 0 and it goes to the right. So you're right in thinking that the domain is all real numbers greater than or equal to 0. Now, the graph would not, the inequality would be all real numbers greater than or equal to 0. That's the domain. It starts at 0 and moves forever to the right. Okay, what about the range? What unit is used for the y variable? You're right, the company value in dollars. And how about the range? And you're right there as well. It starts at some number there on the y-axis. In this case, I eyeballed it at $45,000. And it's all y values in dollars greater than or equal to the starting value of 45,000. Now, you wouldn't have known 45,000. I eyeballed it at 45,000, but it starts somewhere. It always has to start somewhere. We could have said 50,000, but in this case, 45,000. So all y values greater than or equal to 45,000. Number 6, this graph indicates the projected town revenue since town managers report. Along the x-axis is the number of years. So starting at some point time 0, we have a number of years since, again, since the starting point. And the domain. Well, we've had enough practice with the past problems to say that the domain is all x values greater than or equal to 0. And now, how about the y variable? What unit is used for the y variable? Well, it's revenue in millions of dollars. So town revenue in millions of dollars. And now for the range. What is that starting value? What does it look like it starts at right here? Because it looks like it's going to go up. Well, I'm going to eyeball it at 2.5. So we're going to say that the range is all y values greater than or equal to 2.5 million. All real numbers greater than or equal to 2.5 million. Starts at 2.5 and goes up from there on. Never goes below 2.5. Number 7. This one's interesting, probably a lot trickier because it's a decay function. Decay functions will have trickier domain and range considerations, or domain and range expressions. So let's see. We know that domain goes left and right. So domain is going to be left and right. Okay, I'm getting ahead of myself. What unit is used for the x variable? You're right, this year's fishing season. And so we go from the start of the season to halfway through the season to one full season. And then it stops. The game warden is saying no more fishing, and they stop people from fishing. Well, can you imagine if they had left a lot of fishers to fish? They would bring the stock of fish to nothing, or they're actually never to nothing, but they would bring the stock of fish very low, dangerously low. So they stop the season at a certain point. And the game warden says, no more fishing. We need to allow the fish to grow their population so that we can have another season next year. So what is the domain from left to right? What do you think? Oh, you're right. It starts at time 0, and it goes all the way to time 1, which is 1 season. What is the unit for the y variable? Once again, you're right. And here's the tricky part. Gosh, this is a decay function, so it starts somewhere at the bottom. The way we express range, is from the bottom to the top. So, gosh, what is that? What is that? It's close to about 50,000, but a little bit more than 50,000. Then it goes all the way up to about 135,000. Okay, so let's see what I have here. Okay, 50,000. So it starts down here at 50,000 and it goes all the way up to 135,000. So we can say that the range is all countable fish. Remember, countable, we can never have half of a fish. How can a half of a fish be swimming? How can even baby fish are still counted as fish? So all countable catfish greater than 50,000 and less than 135,000. So this lake is stocked with 135,000 fish initially, and by the end of the season, it only has 50,000 fish left. Oh, the inequality is y. We can read this a couple of ways. We can say that all y values greater than 50,000 and less than 135,000. Another way to read this inequality is all y values between 50,000 and 135,000 inclusive. But for purposes of your assignment, you can just write this down, and you can write down that inequality as well. Number 8, we have another one that's a decay function and has a bottom, has a top, has a left, has a right. So let's look at the units first. Here we have the yearly average amount of trash per household. Along the bottom is the unit used for the number of years since the start of a plan. Okay, now stop and think. What is that domain? From left to right. Starts at 0, time 0, and it goes all the way to time 5. And 5 what? 5 years. So the domain would be all real numbers greater than or equal to 0 and less than or equal to 5. And the inequality, the way it's written, is like this. By the way, you may need to pause this video and go back and copy down all these inequalities, because that is a part of your assignment. It's helpful. It's part of the learning process. So in this case, in this particular problem, it's all y values. Excuse me. In this particular problem, it's all x values greater than or equal to 0 and less than or equal to 5. All right. Moving on to range. What unit is used for the y variable? You're right, the amount of trash per household in pounds. Okay, so the trash, it looks like they have this plan to reduce the pounds of trash per household. How they're going to do that, I don't know. But the graph shows that it's going down to the right over a number of years. So that's the plan. What's the range? Well, we always have to start at the bottom here. So it's going to be from the bottom to the top. It looks like it starts at about 1250. And then it goes up to about 1,500. So the range would be all real numbers greater than or equal to 1,250 pounds of trash and less than or equal to 1,500 pounds of trash. It's right there in between. So we've got this amount right in between, all y values in between 1,250 and 1,500. Okay, that was part 2. We're done with today's lesson. Make sure that you, at the very least, make sure that you've completed your supplemental aid, and you might want to listen to the video again. Hopefully, I didn't bore you. You might, and hereafter, you need to. I would like you to please practice. Give yourself about 20 minutes with the multiplication table, and I'll be changing that up to something a little bit different on our next video. Thanks for listening, and y'all have a great day. Bye-bye.